Welcome to this video. In this video, we will be reading data from an HTML web page, process this data, and do some calculations to answer some questions. I'm pretty sure you'll like this exercise. This is basically looking at data from past football records of the UGA Bulldogs. This website, Sikkim Dogs, provides data about historical games that the UGA Bulldogs played. Take a look at this particular table. This is just aggregate records of UGA versus all opponents. It records the opponent name, the first game, the last game, the number of games, total number of games, name won by UGA, lost or ties. If you look at this table, you can see that it's almost a perfect table, but there are some idiosyncrasies here that we will need to deal with when we scrape the data. So in this exercise, we can either use Beautiful Soup to process the data, and actually you can take a look at the posted solutions. They're using Beautiful Soup. Now, in contrast to the previous exercise, this HTML page provides the data in a table. There is a special pandas function called readTable, which will basically read a table in an HTML file. So we can reverse engineer the page as we've done before, but in this particular case, this is much easier because there is a special function in pandas to do this conversion process. Indeed, the only thing we need to do is to call the function for, readTable from pandas. Actually, it's called readHTML, and this function you can either parse pass the HTML text itself, or you can even pass the URL of the HTML, and pandas will do the request on its own. Let's call this one result for now, since we're not sure about the output here. This is such a handy function. It's kind of creating a shortcut for a couple of steps that we used to do manually. If you take a look at the result, you can see it's a list. This function actually looks at all of the tables in the page and returns a list of data frames. In this case, if you look at the length of the list, it's the length of result, it's 1. So if you take a look at result 0, that's basically our table, the table that we want to take a look at. My only concern in this data frame is that the table itself has some idiosyncrasies. So I just want to make sure that those idiosyncrasies are processed well by pandas. For instance, if you take a look at Georgia Tech, the game against Georgia Tech, you can see that we had 2 asterisks explaining some particular characteristics here due to World War II. Interesting. The same thing happens here with Oklahoma State. The name of the university changed from Oklahoma A&M to Oklahoma State. So what I'm going to do, I'm going to look through the data. There are different ways to do this, but I mean, I can eyeball the data here, and if we look at Georgia Tech, that's basically you're looking at almost 40 records in the data, so I'm going to get 40 records onwards. Georgia Tech, interesting. So I'm going to look at head 20, and let's take a look. And as you can see here, my suspicion was confirmed here. Pandas tried to parse the data, and instead of discarding this row, it decided just to put it in the table verbatim. So we need to take a look at these discrepancies, clean up the data before we do any analysis. Indeed, given this, I expect all of the data types we have here to be text, because even that game, win and loss and tie are numbers, they're not numbers across all of the records. So if I do dataframe.dtypes, I expect them to be all objects, which is indeed the case. All right. So there are a couple of solutions to this issue. One of them is to manually fix these offending records. There are probably 2 or 3, maybe just 2 in this whole thing. Or what we can do, we can try to force convert these columns, first game, last game, GWLT to numbers, and use the option coerce to create null values when these the values of these columns cannot be converted. Like in this case, I get a null value instead of Georgia, discredits, losses, etc. So I'm going to go with this first option. I'm going to convert all of the data frame to be numbers. Now what I'm going to go first, I'm going to save opponent, because opponent in this case is not a number across the board. So what I'm going to do, I'm going to set index to be opponent. This also makes sense because that's the natural index of this data frame, not The next step is to use the function pd.toNumeric. Now in this case, I want to apply this function on all of the values in the data frame. So I'm going to apply pd.toNumeric here. The problem here is that this function's default behavior is to raise an error whenever it cannot convert the value to a number. In this case, it cannot parse a string to a number, obviously, so it's going to raise an error. We want to provide an optional parameter called coerce to make it create a null value instead of raising the error. So what I'm going to do here, I'm going to create an inline function. Lambda x is pd.toNumeric x, and here is my opportunity to provide the optional parameters, which I believe was errors. Let's check the documentation of this function real quick. Errors, the default value is raise. I don't want it to be raise, I want it to be coerce in order to provide a null value. So I'm going to say errors is coerce in this case. That will basically fill in null values here. So if you take a look at the value associated with Georgia Tech, is going to be a null value here. So that, I believe it was in rows. I need to use iloc because the index is no longer a number, so I can look at 40 to 47 maybe. That's Georgia Tech here, and that's the offending row. It has been filled with NaN. So what do we do with these NaN? Drop them, right? So here I'm going to drop Na. Now once I drop Na, I expect 2 rows to be dropped. So this is important just to make sure I'm doing the right thing. I expect instead of seeing 141 to see 139. That seems to be the case. So I'm going to store this one as my next data frame data, and I'm going to check the data types, D types here. And I've got all of them to be numbers, which is what I expected. So this concludes the first part of the exercise, which is basically getting the data from the HTML web page. Now the next part is asking us to do some calculations. That's an example of sport analytics. There are 2 questions. What's the first team that UGA played against, and what are the most challenging opponents? Well, the first team is basically the team which has the earliest first game. So what we can do, we can sort values first game, and we can see that Georgia played with actually 2 teams in 1982. So in this case, there are 2 answers to this question. The first team that UGA played against. So what we can do here, we can get the date of the first game, which is 1982. So I can do iloc 00 because I'm sure that this value is at location 00. That's 1892, and then I can go back to my data and pull data in which data first game was equal to that thing. So first game is equal to FG, and this is a mask, and I'm going to use the mask here to get this. If I'm interested in the name of the opponents, I'm interested in the index, and if I just want a list of these names, I can convert it to a list. The next question is asking us to report the most challenging opponents. So this is not a very well-defined question. We can define our own criteria because this criteria was not provided to us. It probably has to do with the number of games that UGA won, percentage of games that we won against these teams. So there are two options here, and again, this is not a very well-defined criteria. We can look at the percentages of game that UGA won across all of the games, across all of the boards. We can also look at the ratio of winning to losing, since tying is not very meaningful piece of information. And again, this is a criteria we're defining because the question itself is not very clear. So let's take a look at the criteria of winning divided over the total number of games. Actually, it's the opposite because it was asking us for the most challenging opponents, not the most easy opponents. So we're going to look at the ratio of game lost divided over total number of games. So that's basically data lost divided over data G. We can multiply by 100. This one is not a big deal because we are going to sort this anyhow. We want to sort in descending order. And again, this is a series. So let's call this one percentage lost. And let's sort percentage lost by values. And I'm going to make ascending is false here. Now, let's take a look at the first 10 items in this list. The problem in this list here is that while it's true that we've probably lost all games against Stanford, you probably did not play so many games against Stanford. Maybe it was only one game, right? So while it's true that, well, we lost against Stanford once, it doesn't take into account the number of games that we played against Stanford. Again, this is something that maybe we want to kind of incorporate in our criteria of being challenging. So maybe we want to take into account, instead of lost over G, maybe lost divided over W. This case, we will get many, well, infinite values in this case, not values that we want to drop. But it will take into consideration the number of games we played with, because we played at least 2 games that we won one and lost the other, right? And you can see that here the data makes more sense. Like you can see that Alabama is a more challenging game than others.